In section 5.5.63, suppose a shipment of 125 electronic components contains 4 defective components. To determine whether the shipment should be accepted, a quality control engineer randomly selects 4 of the components and tests them. If one or more of the components is defective, the shipment is rejected. What is the probability that the shipment is rejected? Now, the phrase one or more means greater than or equal to. So we wish to find the probability that 1 or 2 or 3 or 4 of the components are defective. Notice that these events are mutually exclusive. Therefore, the probability can be expressed as the follows. The probability of 1 or 2 or 3 or 4 defective is taking the probability of 1 defective plus the probability of 2 defective, and so on all the way to 4. Now, instead of computing each of these probabilities, the complement of 1 or more of the randomly selected components are defective can be used, which would make this much simpler. So the complement of 1 or more defective components is no defective components. The complement rule states that if an event E represents any event and the complement E to the C represents the complement of E, then the following must be true. So the probability of E is equal to 1 minus the probability of its complement. Thus, you would have the probability of 1 or 2 or 3 or 4 defective is equal to 1 minus the probability of 0 defective. So we're going to use this formula at the end of the problem. Now, the probability that none of the components chosen are defective is found by calculating the number of ways of selecting 4 non-defective components divided by the number of ways of selecting 4 components from 125. So, what we're going to do is that since the order in which the items are selected does not matter and the items cannot be selected more than once, therefore combinations will be used to solve this problem. So we're going to use the formula for combination. It says since there are 125 minus 4 equals 121 non-defective components. So now we have a total of 121 that's non-defective, and the number of ways of selecting 4 non-defective components out of that 121 is 121 combination 4. So we're going to go ahead and calculate that using the formula. We have 121 factorial divided by 4 factorial times 121 minus 4 factorial, which gives us 8,495,410. So that gives us the first part. And so again, going back up to here, okay, it's saying here that we want to find the probability that none of the components are defective is defined by calculating the number of ways of selecting 4 non-defective components. So we've done that here. Okay, now the second part to this is that we need to divide it by the number of ways of selecting 4 components from 125. So now we have to compute that, find the number of ways of selecting 4 components from 125. So now we're going to go ahead and then use that combination formula, now using 125 as n, and we're still using r to equal 4. So 125 factorial divided by 4 factorial times 125 minus 4 factorial gives us a total of 9,691,375. Now again, going back up here, it says we need to divide that. So we're going to calculate the probability of selecting 4 non-defective components. So the probability of selecting 0 defective components is taking the first combination and dividing it by the second combination. So therefore, we're going to take those two numbers and we're going to get approximately 0.8766. Thus, the probability that the 4 randomly selected components are not defective is 0.8766. And to determine the probability that 1 or more of the randomly selected components is defective, we're going to use that formula at the beginning of the problem to subtract it from 1. So the probability of 1 or more defective is equal to 1 minus the probability of 0 defective. So 1 minus 0.8766 gives you the probability of 0.1234. Therefore, the probability that the shipment is rejected is 0.1234.